Hello, we are looking at Module 4, Homework A, Tab 4, Part 5, and this is the limiting distance speed. So our goal is to calculate the limiting speed, lowercase v, of the charged particle, the p, as it is accelerated from its initial position, which is the origin, along the axis of the charged semicircle. So this problem involves the conservation of electric potential energy into kinetic energy. When the charged particle is released from rest at the origin, it is repelled by the charges on the semicircle. As it moves away, the electric potential of the system decreases and the kinetic energy of the particle increases. By the conservation of mechanical energy, the total energy remains constant, so the initial potential energy, capital U, is fully converted into kinetic energy as the particle moves far away from the charged semicircle. So the kinetic energy, capital K, of the particle of mass, lowercase m, and speed, capital V, is going to be capital K. Oh, why am I writing white? It's not supposed to be there. K is equal to 1/2 times by lowercase m times lowercase v squared. At the limiting speed, when the particle is far away from the charged semicircle and all potential energy has been converted into kinetic energy, the entire initial potential energy, capital U, is converted into kinetic energy as so. So capital U is equal to 1/2 m times v squared. So now we have to solve for the limiting speed, lowercase v. To find the speed, we have to rearrange this equation. So it's going to be lowercase v is equal to 2 times uppercase u, it doesn't look like, uppercase u, all divided by lowercase m. And if we take the square root of both sides, we're going to get lowercase v is equal to 2 times u, all divided by m, to the power of 1/2. And so now we know from the previous, previous part, we know that the electric potential energy U at the initial position is given by capital U is equal to lowercase q, no, it's nothing like a q, lowercase q times lowercase k times uppercase q, all divided by uppercase r, where q is the charge of the particle, which is the p. Capital Q is equal to capital N times lowercase q, which is the total charge of the semicircle, and r is the radius of the semicircle. And if we substitute the expression for U into the equation for V, we're going to, why did I write on this side? I'm going to go ahead and move all of this over here so I can have an infinite space working down and to the right, because we write from left to right. Okay, so where was I? So we substitute the expression, lowercase v is going to equal to, in parentheses, 2 over lowercase m, multiplied by lowercase q times lowercase k times uppercase q, all divided by uppercase r to the 1/2. And we can simplify that to give us lowercase v is equal to 2 times lowercase k. I need to do better at writing in general. Times lowercase k times q, all divided by lowercase m times uppercase r to the 1/2. And because we know that uppercase q is equal to n times lowercase q, the speed can also be written as lowercase v, does not look very lowercase, is equal to 2 times k times q times n, all divided by m times uppercase r to the 1/2. The limiting speed, lowercase v, of the charged particle as it accelerates away from the semicircle is going to give us lowercase v is equal to 2 times u, all divided by lowercase m to the 1/2, and that's going to be our answer. So now we can also go ahead and rewrite that, and we can get this answer. So these are, I think the system will take either of these, but yeah, that's the answer. I hope that helped.